Hello, my name is Ebenezer Safwedu. I'm a business strategist and a data specialist. Welcome to today's session. In today's session, there's a special interview with Vespa Nati. He is a CEO of Vespa Lab Systems. He has numerous years of experience in database design. In this episode, we are going to interview him on database design, how databases are created, and the relationships, and all that has to do with database design. Stay tuned as Vespa Lab takes us through database. Hello, Vespa.
Yeah.
Welcome to my YouTube channel. How is business?
Oh, business is good.
Can you please tell us about yourself for my viewers' sake? If you can take us through your profile, who Vespa is and what you do. Hello, Vespa.
Yeah. My specialty is into computer science. And currently we design and we develop softwares. But we start the design from the database level to the front end, as we always see it in the browser. One of our major products is also into inventory management and accounting. And we've been in the industry for the past 14 years. And we've been working for over 100 institutions.
Wow, that's impressive. So how did you get here as a software developer or computer scientist or whatever name you would give to what you do?
Oh, it all started with a 3-month course that I did some years back. And it was on a language called Visual Basic. And God being so good, the tutor taught us how to design and develop a package that we can sell on the market. So from there, I took it upon myself to research deep into how it is done from the theoretical point of view. He taught us from a practical point of view. And that's when I came to realize that there's a lot into design, as in how to talk to the customer, get the requirement of the customer, and break it down into the various parts. As in, if it is a software, we have the database, then we have the business logic. Before it comes to, you come to the front end. That is what we always see, the buttons that you click to make things happen.
All right, thank you.
So that is
what I sought to help my viewers with is any special for training as an educational background.
My background is into computer science.
Yes, but
and also
what school did you go to?
KNUST, to be specific.
And what courses?
Computer science.
Okay. Let's carry on.
Okay. Looking at today, we are in the digital age, and the success of every organization is dependent on data. So if you look at what is on the screen, we have the big digital companies in the world, which is Facebook, Google, we have YouTube, Pinterest. All of them uses data, and their success is based on how organized their data is.
Okay. So you're saying that how well an organization organizes its data can be a source of competitive advantage, especially in the data world that we are.
Yes.
Okay. Can that be also be said for the inverse, in the sense that if you do not organize your data well, that will be a liability?
Yes, it's going to cost the business a lot. So
on that.
Is that?
If you could expatiate on that.
Yes, the reason is, to have the competitive edge over your competitors, you need to be able to query information at any point in time. So when your data is not organized, it takes a very long time to get information. Let's say management would like to take a decision within the shortest possible time. If your data is not organized, it will take days. It can even take months to fish out that information, and it can cost the business a lot. So that is why it can become a liability if your data is not organized to the business.
So what you're trying to say is businesses that probably have data in Excel sheets, and when probably decisions have to be made, somebody would have to prepare it and probably send it over mail or do it in a PowerPoint. It will take some time before it's gotten. It's not readily available. All these are bad practices that can cost an organization.
Yes.
All right.
Normally, if it is done over years, let's say it's a practice that has been going on for the past 3-4 years. That's when you see how liable it is.
All right. So you can continue.
Okay. So data can be acquired through several means. We can acquire data through normal sheets. We can acquire through our computer, our daily work on the computer. And it needs to be organized. If data is organized, it makes analyzing such information, it makes the analysis very easy, because you can fish out any information at any time.
Okay.
You can fish out information at any time. So that is what we are seeing. So as we are acquiring the data, there have to be a central point where the information can be stored, and it needs to be organized. So how organized your data can be an asset to the business. An asset that gives you a competitive edge over your competitor, because management can easily get their reports to take decisions. They can know if it is, they can know what is happening. They can view their reports in any visualizations that they want in any way. So it helps the business to grow. If it is from the monetary point of view, it helps management to know the sales they are making, whether they are making profit, and all that. And all is dependent on how organized their data is. If
this particular slide that you had, it reminds me of the old filing system. And that, I mean, we used to have filing system. It's the same principle, I guess, that if you have a very robust filing system in some 20 years, 30 years ago, always accessing files or information was very easy. I mean, it took lesser time than go through a stack of information or a stack of files before you get them. So if you label them properly, you arrange them properly, it was easier to always retrieve files. Is that the similarity between the filing system and the current databases?
Yes. Yeah, so for example, some years back, let's say if you go back to your school, maybe your SH to get your certificate, they will tell you it will take, you have to sit down from maybe morning to evening before they can fish out your information for you. Sometimes they will even tell you to go and come the following day or a week. But today, due to how organized some of our institutions are, some of our institutions are using software, so immediately you get that they will ask you specific information as maybe your index number or your ID or anything. And immediately when they input the ID into the system, it pops up your information, and they can easily print such information for you.
Okay.
So if this information or data is not organized, it becomes a liability to the business. One, it halts processes in the organization, as in it makes information flow from one point of the organization to the other. It makes it very difficult because every information that you need, it will take some time before you can get certain information to take critical decisions. So that is how it becomes.
All right.
So this brings us to database management system. So here, we need to, as we've been saying, we need to organize our information, and this information is organized into what we call a database. So it can come in any form.
I think
as it can come in.
I did an initial video concerning data and databases. If I get you right, currently we have a lot of data around us, and data is normally the raw facts. And to be properly, to actually properly assess them and readily get them for analysis, which will give us information for decision making, we need to organize them in a database. And to also run the database properly, there has to be a system around it. And that's what you are taking us through, right?
Yes.
Okay.
So the DBMS, as a database management system, helps us in the data retrieval, and it helps us in the storage, because when we have a database, let's say in an organization of 100 employees, all these 100 employees will be accessing the database concurrently, and those assets needs to be managed. As in, some will be saving information into the database, some will be retrieving. So that is where DBMS is very important. So it sits on the database and help us to access the database.
Okay. And you have the software.
We have several,
if you could go back, you had a software application also in there, and the business logic. How does that relate to the entire system?
Okay, so what happens is, before we can get the information that we need, normally there's a software that sits between the user and the DBMS. And the software communicates with the DBMS through the business logic. So depending on what we want, let's say we need a report in a structured manner, or we need a visualization. Somebody called a software developer will say somewhere and get this visualization for us with maybe in the form of a code. And that code will communicate with the DBMS to fish out the information in that visualization that we want. Let's say in a bar chart or in any form that the user wants. So that is where the software application or the business logic becomes important.
All right.
Okay, so we have several kinds of DBMS. And there's one popular one called Relational Database Management System. This comes in the form of relation. And an example is what we are having there. This is an entity of students where we have a student ID, we have the name, we have login, we have age, and we have GPA.
So this is a sample table. I mean, we'll call it table as a layman. That's what I see. But you call it an entity.
Yeah, we call it an entity. So we might have several entities and they'll be related. As we go on, we will use university as a case study. We will know how the university system is and how the various entities in the database, how they are related using the relational database management system.
So if I get you, an entity is like a table or maybe about a related number of things that are combined in a table with, I mean, each column is related in this particular table. So the SID, the name, the login are all connected in a way to the name.
Yes.
This whole thing will be called an entity or a table for student.
Yes.
So that entity holds more attributes or dimensions or information about the student in probably column forms.
Yes.
All right.
So when we are designing a database, there are some steps that you need to go through to accomplish the design. So what you start with, the requirement. At the requirement stage, it's all about fetching information from the customer or the organization. So if we take the university as an example, you normally want to know the entities in the university. So you can ask questions like, let's say, what are the departments in the university? So the university should give you all the departments, all their departments. Then they will list all their departments for you. Then you also ask the kind of people in those departments. So that's where they can talk about lecturers, they can talk about students, they can talk about, when you ask them how are they related. So they can say that lecturers teaches courses. And lecturer teaches courses, and lecturers, every lecturer too has some number of students that they train. So that is how you fish out this information. And through that, you can lay out your entities. So after laying out your entities, now you go to the conceptual database design. Here you pick all your entities, then you now asks about their attributes. So for example, the student, we would like to know the student ID, the student name, the student login details. The same with the lecturer. You want to know the lecturer's name and the lecturer's ID. You want to know the courses being taught by the lecturer. And we also want to know the courses that the students have been enrolled in. When we go to the logical database design, that's where we are physically creating the tables in the database using the DBMS. So this is what we have. As I said, the requirement analysis or case study of a university contains these entities, as in student, faculty, courses, classrooms. Then the relationship, student enrollment in courses and faculty, and student use of classrooms. So these are some of the entities and relationships that you get during your requirement analysis. Then during the conceptual, this is what we have. We pick each entity. So if we pick students, what are some of the attributes of the students? We have the ID, which is an integer. So here you are going down. So we are seeing the design itself. And we are doing, we are giving them data types. As an integer, the name is a string, the login is a string, the age is also an integer, and GPA is decimal. So the same applies to a lecturer. We have a lecturer ID, which is an integer, and we have the name, which is a string. And we have courses. So the course, I will give it an ID, then we get all the names, then we get the credits of the courses. Then we want to know the courses that students are enrolled in. So that's the relationship between course and student. So that one, to the same way, we would like to know the ID of the student and we would like to know the ID of the course and its grade. They also want to know the courses being taught by the lecturers. So that's a relationship between the courses and the lecturer. So that table takes the ID of the lecturer and the ID of the course. So in a diagrammatic manner, this is what we have. So we have the students. We have the students.
Hello.
We have the course. Hello?
Go to the previous slide.
Okay.
So you talk about the teachers and the enrolled. Those ones are not too clear. For students, lecturer courses, we see them as, I mean, they're about the course, there's about the lecturer and things that are related to the students. But when you talk about enrolled, why the use of the noun and verbs interchangeably?
Okay, so the nouns are the entities. As in student, it's a noun. Lecturer is a noun. Courses is a noun. And the enrolled and teachers are verbs. So the verbs are the relationships. So if you look at enrolled, a student needs to enroll, or let me put it this way, needs to register a course. So they enroll in courses. Automatically, if you enroll in a course, the course will tell you the lecturer. So all that we need to know is we are enrolled in these courses. And when you get to know the course you are enrolled in, if you want to know the lecturer, there's a relationship between courses and lecturers. So depending on that relationship, automatically you will know your lecturer.
All right. I think if I'm seeing some trend here, for instance, the student has an SID. The lecturer has an LID. Are these what you call the primary keys? That's the unique identifier that you put in every table or every entity so as it distinguish that particular entry.
Yes. Yes. So as we said, our data needs to be organized. So due to this organization, we always give a primary key to each entity. So that we can easily fish out a student depending on its ID. Because if we use the name as the primary key, it might conflict. Because two students can have the same name, but the ID is always going to be unique among such students.
Okay, so if I get it, your now entities, which are more like a dimension table or table that contains issues about a particular noun, have unique IDs. So the student has a unique ID. Normally, I'm sure that is what we call an index number. So what the student will call an index number is actually the unique ID in a database, right?
Yeah.
Okay. And the lecturers too have an ID. So in this case, we are designing something for, let's say, university. So you have identified students as a unique group that data will be collected or attributes of them will be collected. And the attributes are including name, login, age, and GPA. Then in lecturers, I see LID, which is the unique key. You have integer, I name, and string. That's the lecturer name and a string, which is a string.
Yeah.
Then I see CID, which is also an integer, and the C name, that's the course name, which is a string, and the credit hours, which is an integer. Then in the enrolled, when it comes to the enrolled and the teachers, which is the nouns that you talked about, that which is the verbs that you talked about. So the nouns are related. When the noun takes an action, it relates to a certain, so if let's say a student enrolls in a course, it therefore connects the student to the course table. And that will become the enrolled table. So I see that the SID in the student table comes then into this enrolled table, as well as the CID then comes into the enrolled table. So those are two foreign keys that have come into that new table, which is as a result of the action taken. Is that it? Hello, Vespa. All right. So when it comes to the teachers,
Yeah, that's it.
When it comes to the teachers, to the same, the LID, which is the teacher or the lecturer, comes into as a foreign key into the new table. Once the lecturer, whatever he teaches, comes into the unique the teachers table. And also I see CID, which comes from the courses. So whatever the lecturer teaches is linked. So whatever action a noun takes in a certain way creates a linkage between two nouns, and therefore creates a new table, which is related.
Perfect.
All right, you can continue.
Okay, so in our physical database, this is what we are going to see. So we see that here our primary keys are showing clear. When you look at the students table, you see that the SID is the primary key. Then we have other attributes, which is the name, login, age, and GPA. The courses to the same way, we have the course ID and the name. Then we have the lecturer ID and the name. We realize that there is a relationship between the course and the lecturer, which is teaches. That's the relationship. So we have the lecturer ID and the course ID. And we have also a relationship between the course and the student called enrolled, which we have SID, the student ID, the course ID, and the grade. We could have even gone further to create a relationship between the student and the lecturer. But that one will be three, because a student can know its relationship with the lecturer, depending on the course, as in the enrolled. So we can also create that relationship. That can also be created.
And that would be
so that is
more of a fact table that anytime a student enrolls in a course and the lecturer is teaching that course, it will be entered in that particular entry, and you therefore populate from there.
Yeah.
All right. So if I get it, I mean, you have entities which talk more about the nouns, which in some cases they call the dimensional table or dimensions table. And you have the actions being taken, which becomes the verb, which then becomes the transactional or the fact table, which keeps on changing because every time some student is enrolling in a course and a lecturer is taking up that course.
Yeah, perfect.
Okay. So once you design this, once it's ordered in this way, anytime that a query is made from the software itself or decision has to be taken that which student is actually taking which course or what is the grade of the student, we can easily go into the database and pull it.
It can easily be queried.
All right.
Let's say we want a student, we want a particular student details at any point in time. We can go in depending on the student ID and fish out that student. We want to know the course is being enrolled by a particular student. We can go into the enrolled table and we can fish that information easily because this is a one-to-many relationship, meaning a student can enroll in two or more, one or more courses. So we can easily query that information. So as we can see, any information can be queried. If you want to know the number of courses that is being taught in this particular university, we can go into the courses table and we fish that information. If you want to know the grade of every student that enrolled in a particular course in a particular semester, we can go into the enrolled table and we fish it. We fish that information. So that's just it. If you want to know the number of lecturers in a particular academic year, we can go to a lecturers table and we can fill that. Any information at all that will come into your mind with this particular database can easily query.
If I get you, what you're saying is a well-designed database would ensure that whenever, if the requirement analysis is done well, if the conceptual design is done well, and the last part was what?
Yeah, the logical
design is also done well. It means that querying data will become very easy. We can always get the data that we are looking for at the shortest possible time. Is that it?
Yes.
So what makes a good database design apart from it being easily queried or the data being easily queried?
Yeah, when we put in proper constraints between the entities. If I say proper constraints, we are able to, we give them proper primary keys, and we also do get our relationships right. Those things are very, very important. Very, very important. So we need to get our entities right, and their relationships too, we need to get it right. As in our foreign keys, we need to get them right. Because
So what you're taking us through is one way that you can actually get it right by making sure that the right questions are asked, the right entities are identified, the right relationships are created. And you talked about the fact that there are one to many, especially for the entities to the, that's the noun tables to the verb tables are sometimes many to one or one to many.
Yeah, we also even have many to relationships, depending on the kind of relationship.
Okay. I think
anytime you are relating an entity to another entity, you have to ask those kind of those relationships, you need to ask whether it is a one-to-many, many-to-many, or many-to-one. You need to ask all those questions.
All right. Thank you very much, Vespa. I believe that this is a very good introductory course on database design. I'll definitely interview you again to probably go deeper and advanced. But I mean, you've made us understand that in the world that we have today, data is really an asset, and how well an organization actually organizes its data will determine how quickly and how useful the information they need will be derived. So we cannot do away with databases in our world today, especially when data has become so much. It's important that organizations spend some amount of time, because this is about the collection stage. Before any proper analysis can be done, the data itself has to be arranged or organized properly so as for easy retrieval. You go to some organizations and all that you see is Excel sheets being passed on from one person to the other. There's no security. It's not well connected. So if you want another data or another attribute, like you rightly said, with this particular database, for instance, whatever data or information that the company needs, they'll be able to retrieve it. But if you don't do proper database design like this, I'm sure what will happen is that you now have to either include another column or go and look for an old Excel sheet or an old file and find out where that data is. So it's important that organizations, I mean, before any data scientist can actually do an analysis on data, you have to audit the database design. And that's why today I had the time to interview Vespa Shenate, the CEO of Vespa Lab, to take us through. Thank you very much for the time spent with us, and hopefully we'll catch you later. Have a great day.
Thank you also for the opportunity.
All right, viewers, so you can subscribe to my channel to get more. And next, once we've gotten the database design, we'll be moving straight into some data analysis too in my next video. Thank you very much.